Hi there, folks. This is Mr. Jansen, and I just wanted to go over this homework assignment that you had last night before you guys take your quiz today. So I'm just going to go down through these and talk about some of the answers like we would normally do if I was there. So the first one, with an algebraic type of proof, these are the ones that you should find a little bit on the easier side, just because we're so used to going through this process. Really, it's just a matter of remembering the different properties so we can label them. So in this one, we start with a 5x plus 1 equals 21. The first thing we would do, and again, that's given because it's stated right up here that that is given. All right. And then the proof, that's what we're trying to get to. So the first thing we would do to solve that equation is we would subtract 1 from each side. And so what we do, again, the order of this is kind of important here. We subtract the 1 over here, and then we state what we did. Okay, so we subtract the 1 on our statement side, and then we say, okay, what we did was the subtraction property of equality, which allowed me to subtract 1 from each side of the equation. And then the next thing we do is we divide each side by 5, and again, we're dividing by 5 over here, and then we say what we did, which was the division property of equality. Okay? On this one with the 2-column proof, just filling in the missing pieces of this thing. So the first thing is again the given. C is the midpoint. So that's given to us, so we write that first. And of course the reason for that is that it's given. From there, because we have the midpoint, we can say that segment AC is congruent to segment CD. So these two pieces up here are congruent. And the reason for that is because that's the definition of the midpoint. The midpoint splits it into 2 congruent pieces. All right. The next thing we might say, well, if AC, the segment AC is congruent to segment CD, then I know that the length of AC is congruent or is equal to the length of CD. And that's what this guy right here is saying. Because there's no lines written above this, when you just have AC written that way, remember that means the length or the measurement of AC. All right, and the length of the measurement of CD. And that's why we've gone from congruent to equals. We've gone from these pieces being the same to their actual measurements being the same. All right, and the reason for that, they have over here congruent segments have equal length. If you just put the definition of congruent, that's fine with me, because that's what congruent segments are. They're segments that have the same length. That's how they're defined. Okay. The next thing we do is we replace AC with what it equals from the diagram, which is right here, the 4x. And then we replace CD with what it equals from the diagram, which is the 2x plus 12. And that's, of course, substitution. From there, we just have to start solving this thing. And if I had this equation that's down here, in order to solve this, I would subtract the 2x from each side. So that's what I do. So again, I subtract the 2x, and then I say what I did, which was the subtraction property of equality. Okay? And then from there, in order to finish solving this thing, I have to divide each side by 2. So I divide each side by 2 and find out that x equals 6. And again, what I did was I did the division, and then I stated what I did, which was the division property of equality. And again, remember, with subtraction property of equality and division property of equality, if you want to abbreviate the way I did down here, that is fine. Also, with the division property, if you had said multiplication property of equality, as if you were multiplying each side by 2, that's fine. With subtraction property of equality, if you had said addition property of equality because you're adding a negative 12, that's fine as well. Or because you're adding a negative 2x, sorry. Okay? And then the ones where we have to do them all on our own. This is a little bit more difficult, obviously. But always start with what you have, all right? Start with the given, and then you want to keep making statements. So after I write down the given, I'm going to keep making statements until my statement is this thing right here. All right, and that's how I know I'm done the proof. And as long as I can justify each step, I'm proving that that last thing is true. So I start down here with km equals the 35, and of course that's my given. All right, so then I state the reason. The next thing I do from here, and the reason this problem is a little bit tricky is because we don't really use that km right away. That km equals 35. What's given there, I don't use that immediately. I start thinking about, okay, how can I relate km to kl? And when I look at this diagram, their relationship is really in terms of segment addition. I know that kl plus lm will equal km. And so that's the next thing I state down here. All right. And sometimes, we don't use our given for a couple steps within this proof, so just don't be alarmed if that happens. If the given doesn't give you anything else but what it is, then try looking for other relationships from the diagram and things like that. All right, so for this one, it's segment addition. KL plus LM equals KM, and that's the segment addition postulate. And notice, once again, I've abbreviated that over here, but segment addition postulate, little piece plus the little piece equals the whole thing. Okay? And then from there, I can take what I just wrote down, the KL plus LM equals KM, and I can replace each piece. Like KL is this thing right here. It's the 2x minus 5. And LM is the 2x. And KM is the 35. So replace each piece. I replace KL with 2x minus 5, LM with the 2x, and KM with the 35. So I'm just doing substitution. All right. So I replaced each piece with its equivalent so that I can come up with an equation here. So that's substitution. And then from there, I just have to solve the equation that's sitting here before me. All right. So I combine like terms. So I do the 2x and the 2x and I add them together. And notice when I combine like terms in this step, the justification that I put over here was simplify. If you want to use that generic term, that's fine. You could just say that you did addition for this one because that's literally what you did, and that would be fine also. And then from there, we add the 5 to each side of the equation, which is our addition property of equality. Then we divide each side by the 4, which is our division property of equality. And again, when we're following those equations, it's always do the step and then say why you're allowed to do that. Let me get rid of those guys because I'm making a mess. And then from here, once I know that x equals 10, we have a tendency to stop here because we're like, oh, we solved the problem, x equals 10. But the problem's not done yet. It asks us to prove that KL equals 15. So we know that KL equals the 2x minus 5. That was given. And if you want to list that as a separate step in here, you could have a separate step listed as, KL equals the 2x minus 5 and say that's given. However, you don't have to worry about doing that. As long as you just say KL equals this thing and substitute that 10 in, I'm fine with you skipping that step. That's a little more tedious than I need you to be at this point. So what we do is we plug that 10 in for x, and really, again, that's substitution. And then after we substitute that 10 in, we have to simplify what's left. So I simplify what's left. And I get KL equals 15, which is what I was looking for in the first place. So now I've proven that that's true. Okay? And the last one, when I look at this, again, I start with the given. So the measure of GFI is 128. And again, the reason for that is that it's given. All right? Just a hair. There we go. And then from there, the 128 doesn't give me anything right away. Again, it's just like the last problem where that given can't really be used yet. The measurement of GFI being 128 kind of just is what it is, and there's nothing else we can conjure from that. So we have to start looking for other things. So when I look at the diagram and I look at how these things are related, I want to know about EFI, which is this angle right here. But the only thing that's given is this entire angle. So I got to start thinking about how are those two things related, and they're related through segment or through angle addition. All right. So if I add up each of these pieces, if I do this piece, the GFE, plus this piece, the EFI, it equals the whole thing, which is the GFI. Okay. So I do some segment addition, and that's what this second step is doing. The two angles added together equal the whole thing. And now from here I can replace each of those pieces because I know what each of those pieces is going to be. Right here, the GFE is the 9x minus 2. So I replace that. The EFI is a 4x. And then my given comes into play now. The measurement of GFI is 128. Okay? So I replace each of these pieces with their equivalent part, and that's substitution. All right? And then from there, it's a matter of simplifying, so I combine like terms. So I combine like terms here, and I'm going to call that simplify. Then I add that 2 to each side, which is the addition property of equality. Then I divide each side by 13, which is the division property of equality. So again, I do each of these steps and then state the reason for it. And now from here, I have x, but I haven't finished the problem. I wanted to prove that the measurement of EFI was 40. So just like before, I have to plug that in. And again, you could have one extra step in between here. You could have the measure of angle EFI equals the 4x, okay, and say that that is given. But I'm not too concerned about that one. We've kind of already stated that, and really it's almost like substitution twice. We replace the measure of angle EFI with 4x and then replace that x with a 10. So I'm fine you not showing that step. Again, that's a little bit more tedious than I need you to be, but just say that the measurement of angle EFI equals 4 times 10 instead of times x. So you substitute that 10 into the equation, and then from there you simplify that. So you do the 4 times 10, which is simplification. Now we can see that the measure of angle EFI equals 40 degrees. Okay? So again, start with what's given. If you can use that to come up with something else, that's great. If not, look for other things that you can come up with based on the diagram or something of that nature. How can I relate that first angle or that first segment to the segment that I'm trying to prove? And a lot of times, really, we're really limited in what we can do. It's probably going to be some kind of angle addition or segment addition for that step. And then from there, start doing substitution. Just think about how you would normally solve this problem, but write out each step and justify how you got to setting up this problem. And you should be fine in terms of doing the proof. Okay? Hope this was helpful, and good luck on your quiz today.